morning, everybody. Welcome here in Theater 1. Glad you all survived the party yesterday and whatever happened afterwards. That's also why we gave it a little extra minutes. If we see people coming in, it's probably going to be more busy in the end. On the other hand, the smaller the audience, the better the discussions afterwards. So, and the better the ideas that might flow from this session. But good, glad that you're here. Glad you survived the Intertraffic so far. This morning, my name is, by the way, Carlo van der Weijer. I'm a member of the advisory board of the Intertraffic, and I'm also left and right moderating some of the sessions. And luckily, they gave me a few of the most interesting sessions. One of them being this one. This is about road markings, as you probably already have seen in the program. And especially road markings now that all these intelligence vehicles are coming up that know how to drive maybe better than we. That's of course the goal in due course, that everything gets safer because these driving machines are going to help us driving. And there's a lot of discussion about this, an almost religious discussion. What does this mean for the infrastructure? If the cars get smarter, will the infrastructure also have to be smarter? Or, as some say, maybe the infrastructure can take a step back in smartness because the cars are so smart. Now, I don't really have a position in this one, so I'm glad that we have a speaker. This is a one-speaker session, but don't give this guy too much comfort. Let's start discussing afterwards, of course. So we will keep about 5 to 10 minutes of questions and answer. So test him. He's good in this. He knows everything. He works at 3M. Rick Nuitens is Regulatory Affairs Manager at the 3M Transportation Safety Division, EMEA, but he's also President of the European Union Road Federation, based in Brussels, Belgium. So he's in the midst of the discussion. What does it mean if cars are so very, very smart in the future, they drive themselves? How should the infrastructure adapt to that? And how should we cooperate? Because if these cars do this quite well in one country and they pass the border where the infrastructure is totally different and they stop functioning, that's also not the way where we want to go. And therefore, it's very important that we have this European regulation. So what is this session about? Let's keep it as interactive as possible. So I see you brought some coffee to stay awake for this one. That's a good sign here. But we have a total of half an hour. So Rick, the honor to introduce you here. And you have about 20 minutes. If you take the full 30 minutes, then it's no discussion. But I hope you will.
Maybe that's
do so.
What I should do.
So let's take the time.
Thanks, Carlo.
Ladies and gentlemen, give a warm welcome, Rick Nuitens.
Thank you, Carlo. So no more introductions, and I will show my new shoes later after the session. So the work that I think first 3M, Transportation Safety Division, is part of 3M company. 3M is very diverse, and as you can see in red, where Transportation Safety Division fits within the big organization of 3M. So we, from Transportation Safety, we cover infrastructure, reflective materials that go on the road, but also go on vehicles. The work that we do, or that we've done together with VEDECOM, the institute in France, was more to investigate how the difference in performance between road markings, how this relates to camera detection, what type of contrast do you get. And the study was not on the road, it was on a test track at Satory, close to Versailles, but also where VEDECOM is based. And as you can see from the slide, and as Carlo already introduced, there is a discussion what type of synergy do we need between the car, the camera, and the road markings, or at least for the lane keeping systems, how can road markings assist in making the cameras work better? And this is also what some studies have shown from other companies, from other institutes, from tests that IRAP has done in Australia together with Ausroads, is that they've investigated a lot of road markings with a Mobileye type camera, and then they came to the conclusion that the better the performance, also the better the camera is reliable, and the lane keeping system will have the confidence. And the test that we've done is also in this regard. Maybe another part which makes it even more important for Europe is that the European Commission is, and I think this general safety regulation is now practically completed. It's kicking off in 2022. New models of vehicles need to have several ADAS systems, ISA, adaptive speed control, and also lane keeping system or lane departure warning systems. And for that, the European Commission and some studies have showed it by Transport Research Lab in the UK, that if you have good markings, if you have a good infrastructure, you will have a good synergy, and it will benefit the cameras, it will reduce accident, but this good infrastructure is not only benefiting the intelligent vehicle, but also the general population, the traditional driver, because if they will see the infrastructure better, then also they will benefit from it, and this will have an additional reduction in accidents. So this was the starting point by the European Commission, and as I said, the general safety regulation is set. This Road Infrastructure Safety Management Directive is still under debate. There is discussion on what should the minimum performance be of the infrastructure. So it's not always an easy debate on where are the threshold levels, what is the minimum that the infrastructure should provide. Because as you can imagine, a minimum performance also relates then to a certain cost and a certain maintenance cost. And this is, I think, where the debate is finally about. But the test that we have done with Vedicom is about different types of markings. And you know that there are the traditional beads that have a refractive index of 1.5 to 1.9. They will only reflect the light when the road marking is dry. Once it starts to rain or a decent cover of water is on the bead, these beads will not reflect the light anymore in the right direction. This layer of water will break the light and additionally, and then the return light will also go in a different direction. In our study, we included some beads that are becoming commercially available that have a refractive index of 2.4. And these beads don't work when the road is dry, but this refractive index is really helping to make the error or to correct the error that a water layer on the bead is providing. So the ideal road marking then, if you want the road marking to perform when it rains and when it's dry, should have a combination of these beads. And we included these in our study. During the day, and this is also where the European norm is about, when this 1436 is providing, let's say, the technical procurement guidelines to the authorities, how to specify a road marking. During the night, it's based on retroreflectivity. During the day, the visibility is based on the diffuse illumination from the environment, the whiteness of the marking or the contrast that the marking is providing is making it visible to the human eye. For the moment, 1436 is really based on human detection, and I think the ultimate goal would also be how can we provide some guidelines in this 1436 that the authorities would know that this would also help camera detection. The test method for wet reflectivity, so the test method, the norm has everything in there already to measure dry and to measure wet and to measure rain. So there is the RW, is a wet test where you pour some water on the marking, you wait 60 seconds, and then you measure the reflectivity. While the RR class is a continuous rain that is falling on the marking, and you measure the reflectivity while the rain is falling or the water is falling on the marking, which is, of course, a complicated test. You can do that in a test site, but as you can imagine, if you do inspection of the road, it's not so easy or even dangerous, if I would say, to perform the RR method on the marking. The test that we've done together with Vedicom is we had a site, a 200-meter straight line where we put markings left and right, And we had a car from Vericom that had the traditional equipment, a camera similar to a mobile eye camera. They also had LIDAR, they had GPS, because we wanted absolutely sure that the markings were detected. It was really a comparative test from markings. It was not really testing ADAS systems. We did not want to compare different ADAS types of technology with each other. The markings, we had 7 markings in there, and these 7 markings were repeated 4 times. We had markings that had good wet reflectivity. We had markings that we had paints as well that had the traditional beads. We had a white line without beads. We also tried to make a marking that was already worn and didn't have beads anymore and even wasn't very white anymore. Then we also had a traditional yellow line that is used, yellow marking that is used in work zones, also with the 2.4 beads in there. And we also, just to be sure that in some cases a blackout marking is used to cover existing markets, existing lines, so the human or the camera shouldn't be confused by the old line, and while the work zone is in place, the camera should follow the yellow line. So we wanted to make sure that the black line wasn't giving any false positives to the system, because you don't want to confuse the system. Here you can see some of the data that we had. I need to point out that the ESD, it says 83 candela. It should be 383. So there's a little mistake on the chart here. But you can see the products were measured according to the 1436. The test took more than a year. The products were applied somewhere in December 2019. So they passed Christmas, and then we started with the test at the end of January. And then during the time, we measured a couple of times as well. We did not expect a lot of wear because the car would never drive on the markings. So the durability of the markings was really not under the evaluation here, because the car would always pass between the lines. We looked at the data, and the images were taken. The speed was at relatively small, 12 kilometers per hour. We also measured at 15 meters in front of the car, because there was not enough resolution in the pixels when we tried to measure at 30, because normally, as people who know 1436, you measure at 30 meters in front of the car, but there was not enough resolution, and we had to come back to 15 meters, and you will see some of the pictures later. So we absolutely wanted to make sure that we found the markings under every weather condition. So as I said, it's not about a commercial ADAS system, because we knew exactly where the markings were. There was also a LIDAR system that kind of cleaned the environment to make sure that the camera did not pick up anything that would be confusing to the measurement. So we had this would be kind of a perfect, close to perfect ADAS system with a combination of different sensors. And then we did the offline processing for the contrast measurements. As I said, we measured at 15. We knew exactly where the lines were. We measured around the luminance of the road, the asphalt, around the marking. And then we measured the luminance of the marking itself. And we used that to calculate we used the formula Weber contrast. That means you subtract both luminances, and you then divide by the luminance of the road. So in a way, contrast of 0 would mean that there is no difference in contrast between the marking and the road. So we looked also from a daytime, a visual point of view, and as you could see, and you will see that with the results of the contrast as well, that it followed a lot the human detection. If a marking looked very white to the human eye, it also provided more contrast to the camera as well. If we looked at how the sun is influencing, so in some cases, the reflectivity of the road or the reflectivity of the water on the road would confuse the and disturb, of course, the contrast measurements as well. In some cases, although we did not do it in our test here, this is a road marking that is sometimes used in the US on concrete roads, where additional black is put next to the marking, just to make sure that also the marking, the whiteness of the marking and the whiteness of the concrete is sometimes not enough to create enough contrast. But we had this type of marking on our site here, but we always measured the contrast to the road. We never measured the contrast to the type that had the black. So just to let you know. When at night, when it rained, you could see that, and this was a kind of a lucky coincidence that we had, because the road had some barriers with reflectors on it, and we saw when when it rains, and these are not active light; these are all reflected light on top of these barriers, and you can see the reflection that the headlights are causing on the wet road. And also you can see how difficult it sometimes is for a road marking to create contrast versus the reflections on the road. So you can see a difference left to right, because each time it's the same marking. You can see that it makes a difference if there is environmental light pollution and reflection. It will make it even more difficult for a marking to create contrast. What we did is we collected the data, and the entitlement was to have 100% data collection. So we had a number of times we wanted to collect the data on each marking, and this is the data that was collected by the system. So you can see if the road marking is getting poorer in contrast, and poorer in quality, if the certain weather conditions started to influence the data input into the system. So it doesn't mean that this has nothing to do with the ADAS being less confident. Maybe in the future you would think that, of course, if the system gets less data, it will say to the driver, I can't help you. So the risk of having your system to switch off is, of course, if it doesn't get enough data. So it's not that this is the confidence of the ADAS system. It's really the percent input data that we had to calculate the contrast. So these are the contrast levels that we then finally calculated. You can see during the day that it was difficult to get above 3. You really needed to have a very white line to get a contrast higher than 3. Although Mobileye says that this is already a very good contrast, and the system would give the highest score. So you can see the more white the product is, and a line without beads is the most white line, and it gives slightly better contrast than the same product with the beads. The beads make the product a little bit more gray, and it has an impact on the contrast. When you go for the night and when it gets rainy, then you could see that the road markings that had these mix of beads provided the highest contrast. So at night you could see the road is very dark, and it's easier to create contrast than during the day. So here, this picture there, you could see how the contrast was measured. The white boxes are the RGB values, the red, the green, and the blue. And there is a formula that can help you that is used to with the RGB values to calculate the luminance of this pixel. And then on the black side, on the road side, you could see that also there are also RGB values which are much lower. So you can use these comparison between the recalculated RGB values to create your contrast. One of the things, and this has already been shown in older studies, is that if you measure at short distance in front of your vehicle, you also have the impact of QD, daytime luminance. Well, the whiteness of the product may help you to have the product detected. Just to close, we also started a little bit of work on the on LIDAR with the University of Dresden, and we are this year we hope to do a bigger project, and also here the LIDAR. This is a Velodyne type LIDAR. You can see the more the marking is reflective, the higher the further, let's say, the look ahead distance of the LIDAR is going to increase, because it's going to receive back laser infrared signals that are returned by the road marking. Also, when you look at different markings with different type of beads, we see the same as with visual light, is that if the marking has the capability to return visible light, it also has the capability to return the LIDAR laser near-infrared light. Also here, a marking that didn't have the beads, the 2.4 beads, when the road marking is wet, it immediately reduced the capability in wet conditions to return the laser light. So with the beads, the performance was getting close to a non-wet situation. So just the last slide before we can have the discussion. The recommendations we make is that with video camera, it's very close to human detection. We see that, and also if I hear Mobileye or other companies, and if I look at other studies, they say that if the human eye can see it, the system can see it. And then we also, black masking tapes, in most cases, there was no false positives. And then these 2.4 beads were really helping to get bad weather or rain detection. For LIDAR, reflection of the near-infrared light, also here, is similar to the visible light. And of course, as the laser is emitting its own light, even during the day, it's based on retroreflection. So in a way, QD is not important for a LiDAR. It's really the reflection of the beads that will make it visible to the LiDAR. And then for the test method, a recommendation, and I think this will be a topic in working group 2, is that if the contrast is important, maybe there we can make recommendations, because you not only need to know the luminance of your marking, you also need to know the luminance of your road surface, and if weather condition would influence it. And if we could have a more practical test of the wet test, of the rain test, that could also be helpful in the future to test and do some inspections there as well. So this is where I want to leave it, and back to you, Carlo.
That's quite a performance so early in the morning. So it looks quite good for intelligent vehicles. The sight of the cameras is just as good as our sight, and if the beats are big enough, then the LiDAR will grasp almost everything, even in the wet weather. That's
if the beats have the right refractive index.
At least a 2.4.
Has nothing to do with size.
Okay, so maybe I'll open the floor first for the question. We have another 5 minutes for questions. Is there already something burning? Except for your stomach due to all the alcohol, I mean, of course. You have the first one here.
Thank you, Ryan from Transport for London. Just that last point about adjusting EN 1436 for contrast. Do you have any thoughts on how that would actually look, how that would happen in practice?
I can't hear your question, I'm sorry. There's too much disturbance.
Sorry, is that better?
Yeah.
Very, very close. Okay, 1436. Mentioned the importance of contrast. How would that actually happen in practice? Because it's easy enough to specify something for a product that you're installing, but how do you compare it to something that's not controlled, which would be the outside road environment?
Well, it's I still haven't completely understood your question.
It's probably the difference between this setup and in practice.
Yeah.
Because in practice, it's everything is different, and also the maintenance is not new. Maybe that's also the things that pop up.
But absolutely right. This is a test in where the conditions of the road are always the same. Let's say the surface is always the same. The only thing we had was different weather conditions. And of course, in reality, you'll have different roads. You have different types of asphalt. You have concrete that is very white. So in a way, and this is what an ADAS system is already doing, it's calculating a confidence level and it's giving it to the driver. Does it see the marking? Does it know where they are? So the practice will be, I think, once that the authorities know what type of road surface they're dealing with, then they can say, okay, I need to go maybe to 160 candelas on millicandelas on daytime luminance, and I can't specify 100. So these are some recommendations that may have to be considered by the road authority that say, look, if my road is very white, then I have to be absolutely sure that my marking is even whiter. So these are the type of things. It's still how practices have to do these. It's all a matter of creating conditions, enough contrast in enough weather conditions. And this is I think the decision that the road authority will have to make based on traffic, based on accidents that have happened and things like that. It's going to be very difficult to make a general recommendation. Yeah.
There's just one very famous thing on the 101 in California where a Tesla didn't follow the rules, the relatively badly maintained road markings, but followed the repair cuts of the concrete matter. Then it moved to the left and this Tesla crashed into a concrete wall because probably the driver was not taking attention.
Yeah.
Is this something that indicates even the importance of well-maintained, good white lines with
and this is
even better in the future?
Yeah, and this is what the European Commission is hoping to achieve is that there will be a regular maintenance of the road markings. I think the systems will also learn is that faults, the repairs, bitumen, reflection, the sharpness of the edge between the line and the road. These are all things that also will help to the confidence of the system to make sure that it's not tracking the wrong repair in the road or a reflective bitumen or things like that. Yeah.
If you see this movie, this clip, then you can see that it might take a while before we have really driverless cars. Any other questions? Now, still have a few minutes. Yeah. Keep the microphone close.
Thank you very much. Can you hear me?
Yeah.
So the question would be then, what do you prefer, to have better quality in terms of beats or better contrast? Because when you said that the video camera is imitating more and more the visual performance of a human being, and when we go to a video camera, then the beats are more important. Am I right or wrong? I need to know.
What was the last? Can you repeat that?
Is he right or wrong? Are we moving with, when we go to LIDAR, are the beats more important than the visual contrast things? That's actually so now with our eyes we look, it's the visual thing that's now more important, but with these new cars is also the beats more important because will we have LIDARs perhaps?
Yeah, I don't know how fast the evolution is going to go. I think today we are looking at in an ADAS system. The ADAS means the driver is still in control and the system is helping him. So, and if the system doesn't have the confidence or the capability to help him, it should warn the driver so that he's back on his own. I think there, based on the, and we know that the systems are getting close to the human eye or similar to the human eye. I think still isn't 100% clear. There may still be situations where the human eye may come to better conclusions. But I think it's going to get more important in the future is that if we get to higher levels of automation, is that we will need redundancy. There will be several systems in the car that will replace the driver. So, and then maybe the sensor and the road marking is going to be one part of the system. There may be real-time AD maps. It will be communication coming from the previous car, and I think this combination of information will then decide if the car can drive into a higher level of autonomy. But for the moment, I think the more that the ADAS can help the driver, the better. And if the road situation has been bad for the day, then maybe you need to have more whiteness. If the accidents are happening there mostly at night, maybe you need to look more at better quality beats and have your maintenance there focusing on this type of performance.
So with it, I want to close this session, but thank you very much.
Yep.
Rick will also be here for more questions. So please come to him, approach him. He's very approachable. You can have his autograph if you really want that. So he's now famous. But the thing is, we are entering now this very important discussion. Do we need LIDAR? Like Elon Musk says, we do only camera because that's also what human drivers apparently have. And if these cameras always take attention instead of looking at the phone, we have a better system. And this is almost religious discussion. Are we going to need LIDAR, yes or no? And this hasn't been thought of. We're not going to solve this within a minute here. But this is an important one because as we hear now, the infrastructure also has to adapt to what the automotive industry is heading for. So let's keep this in control. Speed up the discussion now. We will be back here in 10 minutes where we're going to look at the broader aspect of cooperative and autonomous mobility. So please see that. We have some people that also know their ways to the funding of European Union. So that might also be an interesting subject. That's in 10 minutes from now. For now, thank you for your attention. Rick's still here for questions and answers. And have a nice day. Thank you very much.
Thank you, Carlo.